Why does it say I'm offline? There's it. Seems a bit weird. Right, welcome to today's live stream. We're going to be doing some advanced trigonometry, so mainly using sine and cosine rule, maybe some other stuff with Pythagoras involved in it as well. Let's see how you get on with the first of these two triangle problems. I'll give you 3 minutes to have a go at that one there. Right, here we go. Let's do this question. So it looks quite straightforward, but it's a little bit more complicated than it first seems. So we need to find the area, and we need to have two sides, either side of an angle. And I'm going to look at having this side here. Let's get a pen. And this side here, either side of that angle. But to find this, I can find this side by using Pythagoras, because I can find the distance between these 2 points by turning this into a right angle triangle. And that distance there is going to be from -3 to 3 on the x-axis. So that will give me a distance of 6. And this distance from -3 to 2 on the y-axis will give me a distance of 5. So this distance will be 6 squared plus 5 squared, all square rooted, using a bit of Pythagoras. And that equals 36 plus 25, so that gives me square root of 61. Now I don't know any of the other two sides, and I need two sides to use the formula. A half a b sine c is equal to the area. So what I'm going to do is I'm going to find this side, but first of all, before I can do that, I need to find an angle, because cosine rule is not going to work, because I don't have all the angles, and I don't have this side. And then therefore what I'm going to do is I'm going to use sine rule here, because you need to have opposites. So I need this opposite angle to this side, and then I'll be able to use this opposite angle to this side to find that side. So I'm going to find that angle, and that's quite simple because they all add up to 180. So 180 minus 128.8 minus 19.8 gives me this angle here, and that comes out to 31.4 degrees. So if I now do this angle with this side, okay, I'm going to call this side x. So I'm going to have x over the sine of this angle here, 19.8, will equal this length, which is the square root of 61, over the sine of this angle here, which is 31.4. So I get my calculator, and what I'm going to do, I'm going to do the square root, just move that up a bit, square root of 61, move to the side, and we're going to divide that by sine of 31.4. And then I want to times by the sine of 19.8. Equals. And I get 5.07. I'm just going to check I'm in the right mode. So the shift setup's always worth checking. Am I in the degrees mode? Because I have a feeling I had a different answer when I first tried this earlier, but I might have been in the wrong mode then. So let's just go back and then press equals again. Okay, I am in the correct mode. Just want to should set up 3. Normally you can see at the top which one of these it's going to be, but in this it doesn't. So I get 5.07, and that does make sense actually, because that side has got to be shorter than this side here, because it's opposite the 19.8, which is our smallest angle. So there we go. We get x is equal to, what was it, 5.077, which must mean the calculator I did originally on was in the wrong mode. Let's carry on with this question. So we've got that side now, we've got this side, and we've got this angle. So therefore the area will equal a half AB, so it's these two sides here, so the square root of 61 times by 5.077, and all the rest, always use the whole number. And then I'm going to times by the sine of the angle between them, so sine of 128.8. So grab my calculator so I can just use my answer again. So I'm going to do 0.5 times the square root of 61 times my answer times by the sine of 128.8. Gives me my answer of 15.45 degrees. Not 15.45 degrees, 15.45. And it asks to one decimal place, so that's 15.5 to 1 D P. Okay, moving on to the next question. Let's give you 3 minutes to have a go at this one. No lengths given, no angles given. Can you work it out? Right, okay, excuse me there. I'm just using my phone to keep an eye on the chat because the dashboard on YouTube doesn't seem to be working. So, what we're going to do here, first we're going to find all the lengths like we did last time using a bit of Pythagoras. So we know the distance between, the x distance here from 2 to 8 is going to be 6. So I'm going to square that. And then the x distance between 3 and 1 is 2. So I'm going to square that and add these together. So that's 36 plus 4. So that gives me the square root of 40 for that side. Finding the length for this side, distance between minus the x distance between, if we look at it like this, I'll draw this one in, from minus 4 here to 8 here is going to be 12, and from minus 4 here to 1 here is going to be 5. So this one's going to be 12 squared plus 5 squared, square rooted, and that's 144 plus 25, which comes out to be 169. So the square root of 169 is just 13. Okay, so that side's 13. And then this side, the x distance is 6 again, from minus 4 to 2. Square that, plus the y distance is minus 4 to 3, so it's plus 7 squared, square rooted. So that will give me the square root of 100 of just 85 for that length for that side. Now to find my area, I need an angle. So I'm going to find this angle here. And I'm going to use the formula. I'm going to write in blue just in case it just confuses down here. A squared equals b squared plus c squared minus 2bc cos of A. Okay, so I'm going to find this value here using this formula, and A is obviously the opposite side. So I've got 13 squared equals square root of 85 squared is just 85. C squared, which is root 40 squared, is 40, minus 2 times the square root of 85 times the square root of 40 times cos of my angle. Let's call that angle x. Okay, cos x. So therefore, if I rearrange this, so I get cos x, I'm going to do 13 squared, which is 169, minus the 85, minus the 40, and then I'm going to divide by minus, lots of people forget this minus here, minus 2 times root 85, isn't it, root 40. So minus 2 times root 85 minus root 40. And then I can put that all into my calculator. Let's get a calculator over here so I can see it. So I've got 169 minus 85 minus 40 equals, and I'm going to divide all of that by minus 2 times square root of 85 times square root of 40. That minus shouldn't be there, so there should be a times there, shouldn't it? Get my calculator back. Square root of 40. Close, not there. Move across 1, close brackets there. And I get minus 0.377. So therefore x will equal the inverse cos of that. So let's do shift cos of my answer, and I get 112 degrees. Point whatever degrees. Now, good point to just check your answer. Does it make sense? 13, is that the longest side? 85, 40, it is. So therefore it makes sense this side should be obtuse. Okay, bigger than 90. If this is not the longest side, then this won't be bigger than 90. Okay, so you can always check whether your answers make sense. So now what we're going to do, we're going to put that into the formula for area. So the area will equal half AB sine C. And we got a half times A was the, well, in this case, my letters are changed. So you've got to be careful here. C is my angle, A and B are my sides either side of my angle. So root 85, root 40. You can label a triangle however you want. You just got to get the orientation correct. Okay. So on this formula, it's always the two sides either side of the angle. Is a nice easy way to remember it. And we want 1, 1, 12 plus all the bits in the number. So I've got that in there. So I'm going to use this. So I'm going to do 0.5 times square root of 40 times the square root of 85. Sorry, it needs to go outside the square root. Times the square root of 85. And then we're going to times that by sine of the previous answer. That means I've got all my digits in there. And we get exactly 27. Okay, and we could, for accuracy's sake, to 1dp 27.0. Okay, now that's the only my maths bit, and this is something from a previous section that we did. Okay, it was at the end of the using formula section of my maths, and if I click on there, I get a link to a my maths test, and you can see, look, there's loads of formulae stuff. But at the end there's an advanced trigonometry, and this is exactly the same type of question where you can practice some more questions on my maths. Okay, so moving on. These now, I've got 3 GCSE past questions. I'm going to give you 3 minutes on each to get started, see how you do, and then I'll go through them. go. Let's see how you did. So we want to try and show that y equals 3/4 n. So the best thing to do is we can find this side here by using trig on this triangle, and then from that we've got that side, we can then find this side using trig on this triangle, and then with that and this we can then find this in terms of that. So let's start off with the first triangle here. So we know that that's n and that is 30, and this side is the adjacent. So we know that tan of 30 is equal to the opposite n over the adjacent. So therefore the adjacent will equal to n divided by tan of 30. And you should know that tan of 30 is 1 over root 3. You ought to learn your exact angles. I'll show you a quick way to remember them. So that's also, so a equals that. So if you divide it by 1 over root 3, it's the same as timesing by root 3 over 1. So a equals root 3 lots of n. Okay, so that there is root 3 lots of n. And now I'm going to do, that's triangle number 1. I'm now going to do triangle number 2. And I'm going to draw it in a similar orientation. And I know that this is root 3n, and I know this is 30. And this is what I want to work out. I want to work out x here. So I want to work out x here. And I know that's a right angle. So I've got the adjacent and the hypotenuse. So cos of 30 equals the adjacent x over the hypotenuse, the square root of 3 times m. Cos of 30, well, that one's just equal to root. Let me just, cos of 30 is just equal to, sorry, my brain's just gone blank for a second, root 3 over 2. I should know this. And I got root 3n, okay, on the bottom. So times by root 3n, I get root 3 times root 3 times n on the top, and I get 2 on the bottom, and I get that equal to x. So therefore root 3 times root 3 gives me 3, and I've got 3n over 2 is equal to x. So I now can rub that out, and I can put in 3n over 2. So now I'm going to move on to that triangle there, and I'm going to just draw that over here. So I can keep it all on the same screen. So I've got 3n over 2, and I've got y, and I've got 30. So I've got the opposite, and I've got the hypotenuse. So sine of 30 will equal the opposite over the hypotenuse. So it's divided by 3n over 2. I find it much better to write divide by fractions rather than put it over fractions. It makes it easier to show what's going on in the algebra after. Now the sine of 30 is equal to a half. So I have a half equal to y divided by root 3n over 2. So therefore I'm going to times both sides by 3n over 2. So I get 3n over 2 times by a half equals y. This implies that y will equal 3n over 4 to do my proof and finish off where I got to. So notice I started here, worked through the sides, and then got to what y was equal using 3 lots of trigonometry. Right, next question. Have a go at this one. You have, again, 3 minutes to see if you can get through this. Right, we've probably done quite well to get through that in the 3 minutes, but let's have a go and have a look at this question. So first of all, let's draw the triangle, what it is. So we've got a triangle RPQ. Ignore the sizes of my angles. It's not drawn to any scale. So RP is 8.7 and PQ is equal to 5.2, and we know that PRQ is 32 degrees. And we're assuming that PQR here is an acute angle. Calculate the area of the triangle RPQ. So therefore, we need to find the area of the triangle. We need to find this angle, and then we can find this angle first because we know that's acute. Okay, but we don't know if this is acute or obtuse from this because it depends how big an acute angle this is. So what we're going to do is we're going to find this angle first, then we can find that angle, and then we can find the area. So we're going to use, let's just Q. So we're going to use the fact that sine Q over 8.7 is equal to sine of 32 over 5.2. So multiply throughout by 8.7, you get sine Q equals 8.7 times sine of 32 over 5.2. So we'll get our calculator. So we're going to cancel all of that. 8.7 times sine of 32, close brackets, and divide that by 5.2. That gives me what sine Q equals. So sine Q equals 0.88 and so on. So we'll do inverse sine of that, shift sine of the answer, and we get our angle 62.44, which means this one is going to be, I'm going to use the calculator to work out, only because I want the accurate value. So I'm going to do 180 minus the answer minus 32. And that will give me 85 and a bit degrees. And then I can use the area will equal a half times 8.7 times 5.2 times sine of 88. And it wasn't 88, was it? It was 85. Sorry, I can't read my own writing. There, it's got a bit messy. Sorry, I'll slow down a bit. So sine of 85 and the rest. So I'm going to do shift. I'm going to do 0.5 times 8.7 times 5.2 times sine of the previous value, and that will give me the area. Sorry, it's not pressing equals. Okay, of my triangle 22.55. So to three significant figures, that's 22.6. Now, generally in GCSE, it's better to give more than less because they will say that the answer in this case is between 22.5 and 22.6. So make sure you don't round down any answers. Now, part B of this, if you did not know the angle PQR is an acute angle, what effect would this have on your calculation, the area of the triangle RPQ? What we need to do, and it's a tricky question, so what we need to do, we wouldn't know the angle here, if it's acute or not, because we then won't know the size of that. Because if it's obtuse, this could be our longest side, and this could be a very, very short side. Okay, so it makes it very difficult to find it out. There's two possible angles you could have there. So you'd need to find the area of both triangles. If you didn't know this was acute, you'd have to find this obtuse and find this acute, and you'd have the two triangles you'd have to find out that this could be, because it's quite possible that the triangle could be something like that, with this is 5.2 and this is 8.7 and this is 32. Okay, so it's quite important that we know that that's acute to find this area of this triangle. Okay, one last question. 3 minutes to have a go at this. Off you go. Right, okay, so this is again, you might have done well to have worked this one out in the 3 minutes. So the first thing we need, to find the area of this, we're going to need to find some things. Now we can easily, from the cosine rule, if you've got a side angle side, you can find that side quite easily. So we can find that length. And then once you've got that length, we can use these two and this and the sine rule to find this angle, and then that gives us this angle, and then we've got that angle. We've got one side, and then we've got all the angles, and then we can choose any other side we want using sine rule. So I'll probably use sine rule on this angle, and then this angle here to find this side. So that's how I'm going to go about doing this question. That's my thought process. So let's start off with cosine rule. So I know if I'm going to call this A, okay, the A squared will equal B squared plus C squared minus 2BC cos of A. So A squared will equal B squared 3.8 squared plus 4.9 squared minus 2 times 3.8 times 4.9, and then I'm going to times that by cos of 80. So let's type that all into our calculator. So I'm going to get 3.8 squared plus 4.9 squared. They're going to minus 2 times 3.8 times 4.9 times cos of 80. And that gives me 31.98. So therefore A will equal the square root of all of that. 5.655. Okay, so I've got that. Now I'm going to use that to, and I've written down 4 places because I want 3 significant figures. I've written down 4 places to make sure I've got plenty of accuracy. Actually, I think I'll write more 3/8 as well to give me plenty of accuracy for the rest of the question. Now I need to find this side here. So should we call this B and this B? So therefore we know that sine B over 4.9 will equal sine of 80 over the 5.65538. So I will do sine of 80 divide by my previous answer, then times by 4.9, and that gives me 0.853. and so on. Then I'm going to do inverse sine of that to find out what B is. Gives me 58. So sine B equals that, so B equals roughly 58.56. So I know this is 58.56. Take it away from 180, I can get this value here. And then I can get this value by taking these two away from 180. So let's do that. So I'm going to do 180 minus my answer, just to give myself all the decimal places. So this angle at D, so D will equal 121.4. And then I can find the angle at B. So the angle at B, if I do that, so I'm going to do 180 minus my answer, minus, what was the other one? Can't see it, 25. So that's 33.56. Okay, for there. So B equals 33.56. Now, remember what I said, I need 2 sides either side of an angle, so I'm going to find this side DB here. So I'm going to find the side of DB, so DB over the sine of 25, because that is the opposite angle, sine of 25, will equal whatever A was, which is 5.65538, all over the sine of this angle here, which is 33.56. So I'm going to do 5.65538, should be enough, divided by sine of 33, and actually if I do answer it'll be more accurate because that was my previous answer, times by the sine of 25. Gives me 4.322. So dB equals 4.322. Now I've got dB, and now I can find and I've got this side, so I've got these 2 sides and this angle, I can now find the area. So the area will equal a half times by this side here, 5.65538, times by 4.322 times by sine of 121.4. Okay, so let's put that all into our calculator. So I've got this side times by 5.65538 times by 0.5, and I also got times by sine of 121.4. Hopefully I've done this accurate enough. I would suggest you write all the figures on your calculator out all the time, or use the memory button. I didn't use my memory button. I got 10.43, Let's just check. I think I've got the actual answer from the sheet, and they gave anything between 10.4 and 10.43. So our answer 10.4 is perfectly good enough. This was it in centimeters, so therefore it's centimeters squared. Okay, so that's the sort of level you'll get for trig questions towards the end of the paper. So you get to see the complexity and the number of stages required to solve them. Actually, once you're familiar with going about using sine and cosine rule in this way, you shouldn't find it any taxing. It just takes longer to do. Okay, so hope that was a useful lesson. My next lesson you can find if you click on the link to the my website, and it's got up and coming lessons on there for you to find. The next one, level 6 to 7 next Wednesday, and a level 8 to 9 lesson next Thursday at the same time. Thank you.